and welcome to 101 Code. My name is Moaz Nashawi. If you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can get all the new updates. In this video, we're gonna talk about the first principle of object-oriented programming in Java, which is polymorphism. First, we're gonna see the definition of polymorphism, then we're gonna discuss the different types of polymorphism, and then we're gonna see an example of implementing polymorphism in Java, and finally, we're gonna discuss all the benefits of using polymorphism in our code. So without any further ado, let's get started.
First, what is polymorphism? The word poly mean many and morphism mean forms. So polymorphisms is many forms. The polymorphism is the method in an object-oriented programming language that performs different things as per to the object's class which calls it. With polymorphism, a message is sent to multiple class objects and every object responds appropriately according to the prior properties of the class. Polymorphism describes the concept that objects of different types can be accessed through the same interface. Each type can provide its own independent implementation of this interface. So, in simple speaking, polymorphism is the concept of defining multiple methods inside the same class or inside subclass. Those multiple methods has the same name and different arguments count or different arguments type and different return. The benefits of using this concept is each method can perform a different logic based on the arguments that you provide for it. The first type of polymorphism is the static compile-time polymorphism, and the concept is you define multiple methods with the same name and different argument inside the same class, and we call this overloading. So when you define a method with the same name but you put a different arguments count or different arguments type, this is called overloading inside the same class. The second type of polymorphism is the dynamic polymorphism, and it happens inside the subclass. So if we have a superclass which is a simple caller with the two methods call, and we extend to the subclass of advanced caller here in this example, you can override a method from the superclass in the subclass with the same name and different argument type, and we call this overriding. So to understand this more, let's get to IntelliJ. Here we have the first class. Now we're working on an application of a simple caller. This simple caller allows users to perform calls between 2 person or 3 person. So basically we have the same method which name call, but in the first one we perform a call for 2 person between 2 persons. And the overloaded one, which is also called call, can perform a call between 3 persons. So here, as we said, inside the simple class, it's a static polymorphism. We call it overloading. Let's try to use this class now. Let's first instantiate a new instance of the simple caller, and let's try to do the first one, or the second method, which is the call. So you can see now here I'm giving first person, second person, and third person. So now I'm performing call between 3 persons. If I run this project, I will get the execution of the logic inside inside this method, which is the second one of call. As you can see, we have a print line in here. Now let's see the snippet here. If we say simple caller.call, as you can see, the snippets give us that there is 2 overloaded methods with the name call. So which one you want to use? That defined by the count of the arguments. So if you just insert 2 arguments, like let's say Moaz and Randa, the compiler will know automatically that you are using the first overloading of this method, and it will call it. So based on the inputs that you provide, the method will be chosen. Now let's see the second type of polymorphism, which is dynamic polymorphism. Here we have a class named advanced caller. We decide that we should upgrade our simple caller class, and make our application able to perform call between three guys and also print some messages before the call happen. So as you can see now, first I'm extending the simple caller, and here I'm using the annotation at override to tell the compiler that I need to override the method which name call, which has two arguments. Here in the superclass we have this method which name call and has two arguments, and here I want to override it, so I'm gonna use the annotation at override, and I can now write the logic that I want. You can see I'm upgrading the content. Now I have three print lines. First, please wait. The second one, ring ring, and third, when someone pick up, we calling initialized. So this is overriding, and it happened as we said in the subclass. Now also worth to mention, when you use override, you use the annotation override only when you are overriding a method. Method exists inside the superclass. So here, because we have two string arguments inside this call and the same return type void, here we are overrided because we are writing the same exact argument count and type and return. But let's say we want to upgrade our application, and here we are using a new method with the same name and the same return type, but here now we are letting our application be able to perform call between four persons. That's not considered overriding because in the superclass there are no method with four arguments and the same name and the same return type. So now let's try to use this example. Let's first comment the first, and let's instantiate a new instance of advanced caller class, and let's use the snippets to see. Now if we say .call, as you can see, now we have three methods with the same name. You can choose between them. Let me choose, for example, the upgraded one, which can perform call between four persons. Now also the compiler automatically will know which method to call based on the inputs and the arguments type. So here first person, second person, third person, and fourth person. If I run this project now, as you can see, I'm getting please wait call between 1, 2, 3, and 4. So as you can see, to sort the benefits of using polymorphism in our code, first it helps programmers reuse the code and the classes once written, tested, and implemented. They can be reused in many ways. Polymorphism helps in reducing the coupling between different functionalities, and it's easy to debug the code once you understand what the overloading and overriding in the methods. So that's it for this video. In next videos, we're gonna talk more about object-oriented programming and Java. Until then,
if you like our videos, don't forget to comment, like, and subscribe, and turn on the notifications so you can get all the new updates.